The Flying V is a futuristic plane that a lot of you guys found interesting, to say the least. In the first video I made, people went all out in the comment section asking all valid questions like how are airports going to handle this and how is passenger comfort going to play out? But the most critical question asked was, if this design is so revolutionary, why hasn't it taken over the skies yet? What are engineers discovering in wind tunnels that's making even the most optimistic aerospace experts pause? And who is the other player lurking around the corner? Today we're diving once more deep into the Flying V, but this time more into transition from computer screens to actual flight testing. And we take a closer look at another company working on the same kind of type and how they might be winning the race. You have to keep watching if you want to know all about the recent developments as for the beginning of 2026. Before we start with the video, it would mean the world if you could like and subscribe to my channel because, especially for you, it's completely free. Okay, let's get to it. What if the revolutionary aircraft that promised to transform aviation is now racing against an American rival with billions in funding and military contracts? A few years ago, the Flying V from the Netherlands went viral, promising 20% fuel savings and a radically different flying experience. But as we enter 2026, the landscape has completely changed. JetZero, a California startup, just secured over $1 billion in commitments and is building a $4.7 billion manufacturing facility in North Carolina. Their full-scale demonstrator is scheduled to fly in 2027, with United Airlines already ordering up to 200 aircraft. Meanwhile, the Flying V team at TU Delft continues their methodical research approach. So here's the real question. Is Europe's careful academic research about to lose to America's aggressive commercialization? The Flying V began as a master's thesis project by Justus Benade during his internship at Airbus in Hamburg. Since then, TU Delft has partnered with KLM Royal Dutch Airlines and Airbus to develop this radical V-shaped aircraft where the passenger cabin, cargo hold, and fuel tanks are all integrated into the wing structure. The design promises 20% better fuel efficiency compared to an Airbus A350 due to reduced drag and weight. The aircraft would have the same wingspan as an A350, allowing it to use existing airport infrastructure while carrying 361 passengers in standard configuration. In September 2020, the team achieved their first major milestone, flying a scale model at a German airbase. The 22.5 kilogram, 3 meter wide model successfully demonstrated that the radical aerodynamics could work in practice. Chief engineer Malcolm Brown, controlling the plane remotely via laptop, described the emotional moment after 2 years of intensive development. However, the flight data revealed a significant challenge that still hasn't been fully solved, the Dutch roll problem. In conventional aircraft, the vertical tail fin acts like a weather vane, providing directional stability. The Flying V has no traditional tail, relying instead on winglets and sophisticated computer control systems. During testing, the model exhibited a troublesome yawing and rolling motion that would feel like being on a boat in rough seas to passengers. This isn't just uncomfortable, it's a potential certification showstopper. The team has been working on active flight control systems similar to those used in the B-2 stealth bomber, where computers make hundreds of tiny adjustments per second to maintain stable flight. As of 2026, TU Delft continues researching multiple aspects of the Flying V. Dr. Roelof Vos, the project leader and associate professor at the Faculty of Aerospace Engineering, has teams working on aerodynamics, structural engineering, noise characteristics, and flight behavior. The university has conducted at least 8 test flights of the scale model, with data feeding simulators where KLM pilots are now flying the unusual aircraft virtually. According to reports from 2023, pilots describe it as flying like a normal jet once the control systems are properly tuned. The long-term development plan includes several phases: continued simulator work, wind tunnel testing to validate efficiency claims, building a full-scale cabin mock-up for passenger experience research, and eventually constructing a mid-scale demonstrator large enough for a human pilot. The interior mock-up has been particularly interesting, featuring innovative seating arrangements that take advantage of the V-shape's unique geometry. Because the wing is so thick, designers can stack seats in staggered, three-dimensional patterns rather than traditional flat rows. They've also created social zones in the corner areas where passengers can sit across from each other at tables, completely reimagining the flying experience. But there is a significant psychological challenge. Passengers sitting in the center of the wide cabin would have no windows. Researchers are testing virtual window technology using high-definition OLED screens, displaying real-time exterior camera feeds. But early surveys show mixed reactions. Some find it innovative, others deeply uncomfortable. Hydrogen propulsion has become central to the Flying V's value proposition. The thick wing structure provides ideal space for the large cylindrical tanks needed to store liquid hydrogen at -253 degrees Celsius. While hydrogen would reduce the aircraft's range by about 35% and consume roughly 70% of cargo volume, Dr. Voss has stated this is the necessary compromise for carbon-neutral aviation. TU Delft is actively involved in the EU-funded Goliath project, which is developing liquid hydrogen handling and refueling infrastructure at European airports, including Rotterdam, The Hague Airport. The university's research covers everything from hydrogen combustion in jet engines to airport ground operations for hydrogen aircraft. Separately, the Aero Delft student team at TU Delft made headlines in 2025 by becoming the first student team worldwide to successfully test a liquid hydrogen-powered aircraft propulsion system. Their full-scale Phoenix aircraft, built on a Sling 4 airframe, aims to fly on gaseous hydrogen in 2025 and liquid hydrogen in 2026. This pioneering work demonstrates that hydrogen aviation isn't just theoretical anymore. Now, let's talk about the elephant in the hangar, JetZero. This California startup founded in 2021 is pursuing a blended wing body design, which is similar in concept to the Flying V, but with a smoother manta ray shape rather than a sharp V. The critical difference isn't just the shape, it's the approach and resources. In August 2023, the US Air Force awarded JetZero a $235 million contract to build a full-scale demonstrator called the Z4. In January 2024, JetZero announced they've secured over $1 billion in total commitments, including commercial agreements, government grants, and private investment. The company is investing $4.7 billion to build what they're calling the Factory of the Future near Piedmont Triad International Airport in North Carolina, creating an estimated 14,500 jobs. This represents possibly the largest job announcement in North Carolina history. The Z4 is designed to carry 250 passengers using existing Pratt & Whitney engines, targeting what's called the middle of the market category, between narrow-body and wide-body aircraft. JetZero claims their design will achieve 50% better fuel efficiency compared to current aircraft, significantly more ambitious than the Flying V's 20% target. The full-scale demonstrator is being built by Scaled Composites, with fabrication taking place throughout 2026, ground testing starting in April 2027, and first flight scheduled for September 2027. The commercial interest in JetZero is remarkable. United Airlines signed a conditional purchase agreement for up to 200 Z4 aircraft, with the order dependent on hitting development milestones, including that crucial 2027 first flight. Alaska Airlines provided funding in an earlier investment round. Delta Airlines is providing expertise on cabin layout and passenger experience, with their representatives enthusiastically describing the potential for revolutionary customer service in the uniquely shaped cabin. In July 2025, at the American Institute of Aeronautics and Astronautics Aviation Forum in Las Vegas, JetZero and its airline partners showcased their vision for the passenger experience. The triangular cabin layout allows for a central bar or island area, fundamentally reimagining how flight attendants can deliver service. Delta's Director of Sustainable Skies Lab, Sangeeta Sharma, told attendees that their flight attendants are genuinely excited about delivering a next-level customer experience in this aircraft. The Air Force's interest goes beyond just fuel efficiency. Military logistics depend heavily on fuel supply chains, and a 50% reduction in fuel consumption would be strategically significant for military operations. Additionally, the Air Force is exploring the blended wing body design as a potential platform for next-generation aerial refueling and cargo transport, possibly replacing aging C-5, C-17, and C-130 fleets. As of early 2026, JetZero reports significant progress. They've completed cockpit tooling, are testing full-scale fuel tanks, evaluating wing test articles, and have already conducted flight tests on a subscale model called the Pathfinder, which received FAA airworthiness certification. The company passed its critical design review in mid-2025. All systems are tracking toward that September 2027 first flight target. So what does this mean for the Flying V? The European project continues its methodical academic approach, publishing research papers and advancing scientific understanding. TU Delft has permanent staff and graduate students working on various aspects, with Airbus maintaining involvement. However, there's no announced timeline for a full-scale demonstrator, no massive manufacturing facility under construction, and no conditional purchase orders from airlines. The contrast is striking. JetZero is moving at startup speed with military urgency and massive financial backing. The Flying V is progressing at an academic research pace with university funding and corporate sponsorship. JetZero is building a factory before their demonstrator has even flown. TU Delft is still flying scale models and running simulations. Both Boeing and Airbus remain publicly uncommitted to either blended wing concept. These aerospace giants are masters of incrementalism, making conventional tube and wing designs 1% better each year. Pivoting to a completely new aircraft architecture would require rebuilding entire supply chains, retraining thousands of workers, redesigning maintenance procedures, and investing potentially hundreds of billions of dollars. For them, the Flying V and JetZero represent fascinating research, but massive financial risk. However, the pressure is building. If JetZero's 2027 demonstrator flight succeeds and validates their 50% fuel efficiency claims, Airbus and Boeing will face uncomfortable questions from shareholders about why they're not pursuing similar technology. United Airlines' conditional order signals that major carriers are seriously considering these radical designs, not just as interesting concepts, but as potential fleet replacements for the 2030s. The hydrogen angle adds another dimension. Both designs claim superiority for hydrogen storage, but they're solving slightly different problems. The Flying V's extended arms provide long cylindrical volumes, ideal for high-pressure hydrogen tanks. JetZero's smoother blended design might offer better aerodynamics, but potentially less optimal tank geometry. As Europe pushes aggressively toward hydrogen aviation infrastructure through projects like Goliath, and as liquid hydrogen propulsion technology matures through efforts like Delft's groundbreaking tests, the aircraft best suited for hydrogen could win, regardless of which is slightly more efficient on conventional fuel. There's also the geopolitical element. JetZero represents American aerospace ambition backed by military funding and aggressive commercialization. The Flying V represents European academic excellence and methodical research. This mirrors broader patterns in aerospace development, where American companies often move faster with greater risk tolerance, while European projects prioritize thoroughness and safety. The regulatory path remains uncertain for both. Aviation certification authorities have never approved a passenger aircraft without a conventional tail that requires constant computer intervention for basic stability. The FAA and DASA will need to develop entirely new certification frameworks. JetZero's military contract might help establish some precedents, but commercial passenger certification is a different beast entirely. The passenger acceptance question looms large for both designs. Will travelers trust an aircraft that looks nothing like what they've flown on for their entire lives? Will they accept windowless center seating even with virtual windows? Will they pay premium prices for the novelty? Or will they choose the cheapest ticket regardless of aircraft type? Airlines have learned that passengers generally choose price over experience, which is why economy class keeps getting denser and less comfortable. As we move through 2026, the race is definitely on. JetZero is sprinting toward their 2027 demonstrator flight with massive resources and commercial partnerships. The Flying V continues its careful research progression with no announced demonstrator timeline. The winner might not be determined by which design is technically superior, but by which team can navigate certification, secure airline commitments, and build production capacity first. The tube and wing design has dominated commercial aviation for over a century, but physics and economics are finally aligning to make radical alternatives viable. The Flying V proved the aerodynamics work. JetZero is proving the commercial model might work. Together, they're forcing the entire aerospace industry to reconsider what a passenger aircraft should look like. One thing is certain. By 2030, we'll know whether blended wing bodies represent aviation's future or just an ambitious footnote. The Flying V and JetZero have moved beyond concepts and CGI renderings. They're flying hardware, building facilities, and attracting serious commercial interest. The revolution might not be televised, but it's definitely being engineered. What do you think? Would you be willing to fly on an aircraft with no traditional fuselage, potentially sitting in the wing with no window? The answer to that question might determine whether your grandchildren fly in tubes or wings.